Good afternoon. My name is Rich Nass, and I'm here once again for a 5-minute interview. And today my subject is Lars Knoll of Qt, which is spelled QT, but it's pronounced Qt. And Lars is the CTO, and he is the project chief maintainer. So when Lars sent me his bio, I saw that he was a project chief maintainer, and the first thing I said to myself is, I haven't seen that title before. So, Lars, good afternoon. And what exactly does a project chief maintainer do?
Yeah, good afternoon. I'll try to explain that a little bit. So Qt, or as it's written Qt, is actually a project or a set of classes and APIs and tooling around that. That's been around for quite a while. I mean, the first version was actually produced by a company called Trolltech 20 years ago, and has been developed ever since, gone through a couple of owners. And right now, it has also always been developed as an open source project, or as out in the open. We've delivered the source code to our customers and to the world. And over the last years, we've actually made and turned the whole project into an open source project. So while there's a company behind Qt, the Qt company actually, and I'm the CTO of that company, I'm also the Qt project chief maintainer, which means, for that open source project, which drives the development of the technology forward, I'm the guy who's basically then there with having the ultimate responsibility for, where we go and trying to, help making the project move into the right direction. So as an open source project, you of course need some sort of governance structure, how to make decisions, where you want to go, how to basically figure out, what you do in case of there's conflicts between people and different opinions about what you should be doing. And then, in the end, if people can't resolve these kind of things, then it's in the end my final responsibility to make a call and say, this is where we're going.
Okay, that actually makes a lot of sense. Okay, so you're very heavily involved in software coding, open source, and all that, but I noticed you have a PhD in physics. Does that come in handy in your day-to-day job?
Well, actually, the physics that I learned at university is something that I rarely need. It's clearly, I moved over from physics to computer science. But on the other hand, the education itself did help me a lot. So, during my education, that was in the 90s, we didn't really do a whole lot of, computing or work at computers. Most of it was, experimental and theoretical physics, using, paper, pen, or, doing certain experiments. But what I did learn there, and which helps me tremendously these days, is just the ability to quickly pick up new topics, to read myself into new things. And as you know, I mean, the world of computing is moving extremely fast. So you can never stop learning, and you always have to try to figure out new things, have a look at the latest developments in technology, and learn about them, learn how to use them most efficiently. And this is something that I learned during my education when I was doing, both my master's and my PhD in physics. So it was also then that I started to get my, first deeper contacts with computing. During my PhD time, I had to do some programming. Everybody else was doing that in Fortran still, Fortran 77. And, I didn't like that language. And so I started teaching myself C and C++ and started working with that. But as I said, I think the most important things I learned during my education is really how to pick up things and how to learn new things, how to teach myself, basically.
Yeah, that's a great point. I've heard that from lots of people. The most important thing that they learned in college wasn't actually what they learned, but how to learn.
Absolutely. I think this is the most important thing, and this is something that you usually do learn in college. In school, high school, it's still a little bit more like you get these things thrown at you by a teacher, but in university you really have to start doing these things by yourself, otherwise you will never make it.
Exactly. Okay, so you've been in the software industry for a while now. Let's pick a time frame, say 10 to 15 years. What has been the biggest change from the software developer's perspective over that time frame?
I think a tremendous amount of things have changed. I mean, if you look back 15 years, and that was when I started really working professionally as a software engineer, the whole world has changed. I mean, 15 years ago, it was all about the desktop. We were doing, most of the applications out there that you could see out there were proprietary. Open source was actually something that few people knew about and few people used. And then since then, everything has changed. I mean, open source is something that is everywhere now. Software development has moved, from being pure, mainly focused on desktop and, these kind of Unix systems and Windows PCs, to also, tablets, to other things in the embedded space. At the same time, the level of abstractions have moved up quite a bit in many places. So many of the software engineers are now working, two levels higher up in the abstraction chain, you could say, than they used to 15 years ago. Where 15 years ago, many people were doing, really low-level things. Still now, many people are moving, into doing things at a much higher level of abstractions. I think at the same time, things have changed a lot. We have much better tools available these days that help us do our job. I remember when I started working at the version control system we were using, if people were using one, was CBS 15 years ago, which when I look back now at it is pretty bad. That has changed completely. We have very good version control systems now. People have moved on to almost everybody is using IDEs nowadays instead of text editors, as many people were still doing 15 years ago. These kind of things have changed a lot. But I'm also seeing that it's not quite true everywhere. So, if you look into the embedded space, many people are still using, I think, too basic tooling, and are still, struggling with things that, has been solved for quite a while. And then I'm seeing also on the higher abstraction levels, if I look into people doing web development, other things, I see that, many people, come from the outside, they fall back and they forget about some of these advancements in tooling, suddenly, hack things together again, stop using, decent processes, and stop using especially good tools like version control systems that help them. So it's interesting to see that. From my point of view, I mean, a lot of things have also changed. I mean, when I started in a small company. We were around 15 people. We were not very structured in many of our approaches, and we have now been, over the years, putting in a lot of work in getting things more structured, having, things like a continuous integration system with automated regression testing available, not doing this manually anymore, using some of the agile methods that have been developed over the last 15 years and these kind of things. So I think, in that respect, many things have, changed a lot, at least from how I see how we develop software in our company.
Well, you raised a whole bunch of good points, things that I absolutely want to follow up on. Unfortunately, our 5 minutes is up, so we will have to do that in a follow-up interview. So I thank you very much, Lars. That was Lars Knoll, the CTO of Qt. Thank you very much, Lars.
Thank you very much.